Welcome to In 5 Minutes. We take problem on deflection of beams and we consider simply supported beams. Our problem statement is find the deflection of point C for the beam as shown in the figure. So this is a figure of a beam. This blue line represents the beam and it has one downward vertical load of 2000 Newton at a distance of 2 meter from one end and a clockwise moment of 1500 Newton meter at a distance of 4 meter from the left end, and at the two ends we have the vertical support reactions. So the given data in the problem is we have a simply supported beam and no information is given about the property of the beam, that is the flexural rigidity, which is E into I, is not given. So we'll assume EI as some constant, and in this problem we have been asked to find the deflection at point C or YC. So first we'll assume the vertical support reaction at point A as VA and vertical support reaction at point D as VD. Let's start with the solution. Our first step is to find out the support reactions VA and VD. So we'll find out the support reactions V and VD by using the static equilibrium equation, which is summation of moment about any point is equal to 0 and summation of all vertical forces, that is Fy, is equal to 0. So let's apply the first static equilibrium equation at point A. So we have summation of all moment about point A is equal to 0. Now writing the equation for all the moments about point A, we have our sign convention is clockwise moment is positive, anti-clockwise moment is negative. So about point A we have the first anti-clockwise moment due to this downward force of 2000 Newton acting at a distance of 2 meter. So we have 2000 multiplied by 2. Then we have a clockwise moment of 1500 Newton meter. So 1500. Then we have an anti-clockwise moment due to the upward vertical support reaction VD acting at a distance of 7 meter from point A. So we have minus VD into 7. And this whole summation of moment is equal to 0. So upon solving this, we get the value of VD as 785.71 Newton. Since the value comes out to be positive, our assumption that the support reaction is vertical is true. Now let us apply the second static equilibrium equation, which is summation of Fy is equal to 0. That is summation of all vertical forces is equal to 0. So our sign convention is all the upward vertical force is positive, all the downward vertical force is negative. So we have first upward force is VA and second upward force is VD. Then we have this downward force of 2000 Newton, so minus 2000. This summation of all vertical force is equal to 0. So upon substituting the value of VD from here, we have VA plus 785.71 minus 2000 is equal to 0. So upon solving, we get the value of VA as 1214.29 Newton. Since VA is positive, our direction of VA is upward. So our assumption is true at point A also. Our next step is to write the bending moment equation using Macaulay's method. Consider point A as origin. Let us take a section XX across the beam at a distance x from origin A and move this section from origin A to other extreme end D of the beam. Now writing the bending moment equation about section XX in a single equation, we have for a section XX between point A and B and at a distance small x from point A, considering the left hand side of section, we can write moment mxx, which is also equal to EI to d square y by dx square is equal to, our sign convention is on the left hand side of section clockwise moment is positive, anti-clockwise moment is negative. So we have a clockwise moment due to this vertical support reaction VA at a distance x from section XX. So we have VA multiplied by x. Now we see this is a bending moment equation for a section between point A and B. So let's put it into our first partition. And this equation is valid only between point A and B. Now let's move this section towards the right, that is beyond point B, such that your section now XX is between point B and C and at a distance x from point A. Now if we write the bending moment equation about section XX, by considering the left hand side of the equation, we can write mxx as VA into x, which will be same, then minus 2000 into x minus 2, which represents the anti-clockwise moment due to this downward force of 2000 Newton acting at a distance of x minus 2. Now again, this part of the equation is valid between point B and C, so let's put it into another partition and we say that this equation is valid between point B and C.